So today we're going to start talking about something called a class. We just finished talking about the math class and the character class and how we know there are methods, little blocks of code written, tucked away in those classes so that we can use them to solve problems dealing with strings or characters and so forth. So today we're going to take a look at, up to this point, you've been doing what's called procedural programming, okay, where you just have a whole bunch of lines of code. You have ifs, you have loops, and you have methods, and all of that is tucked into one single program. Well, today we're going to start something called object-oriented programming. And this is where we're going to create code and we're going to hide it, more or less. We're going to hide it in a class, just like the character class. There's a whole bunch of code created and it's hidden in that class. Okay. Now, we're going to write the code, put it in the class, and then we're going to be able to use that class. It's like a new data type. We're going to be able to use it by creating what's called an object of that class. And as you've been doing your code listings, you've created objects of the class rectangle. That's the name of the class, okay? When we talk about creating an object, you're going to hear me use the word instantiate an object over and over and over. Okay? Now, what's going on in these objects? It's self-contained. It's tucked away. There are going to be fields where I can store data. There are going to be methods. There'll be a couple of other things that we're going to see eventually, but it's tucked away. It's off to the side, and we can use it. So once it's written, I can have a demo program that can access what's there as long as I know what's there. Classes and objects. Okay. Inside of it, we're going to have fields and methods. You've seen that rectangle, and we'll talk about it in a minute. And again, we're going to, each object created is an instance of that class. That's why we say we instantiate an object. So let's take a look at creating a class. Now, this bad boy down here in the bottom is a great way to draw up what you're going to have in your class before you actually start to type it up. This is called a UML chart, Unified Modeling Language. It's going to be the layout for the class rectangle. So this rectangle is now a new data type name. Int is a data type name. String is a data type name. Rectangle is a data type name. So when I go to my demo program and I instantiate an object, it has to match this name of my class. So I'm going to have a class called rectangle.java. And when I create it in my demo, I'm going to have to make all of my objects, my variables, have the data type rectangle. Okay, so inside a rectangle, I only need to know two things. That's it. I only need to know two things, the length and the width. That's it. Okay, these guys are going to be called fields. These are variables inside of my rectangle object. I can put 10 of them in there if I want. Okay, so on and so, if I needed more, I would add more. I put a little minus in front of it in my UML chart. That means it's private. Now, the reason this is private is, what if I'm over here writing a demo program, dopey, and I pick a variable named length? Well, that's the same as this. And if this was public, this new length would screw up this length. So we make it private, we're hiding it so that the demo can't get it or change it accidentally. So it's always best to make our fields private. Now, our methods, we're going to make most of our methods public, which means the demo can use these methods. Okay, if I want to say, hey, that length over there, I want to give it a value, I'm going to use the set length method to send a value over and store it in length. Same with set width. What if I want to know the value of the length over there? I do the gets. So I have gets. Notice I have one called get area. That's going to say, hey, go get the area. Now, here's a question. What if I created another variable called area? Okay. And I come in and I say length is 6, width is 4, and area becomes 24 because I'm going to have to calculate it. Okay, so I calculate. Later, I say, oh, I want the length to be 16, but now I go and get the area and I forgot to calculate it again. What am I getting for area? Well, that old 24. This is called stale data because it would need to be recalculated again. So in order to avoid stale data, we don't use variables like area inside of here. When I want the area, I'm going to go recalculate it again. The absolute only things I need over here are length and width. So for that reason, we stay away from having a ton of variables over here that could become stale. Does that make sense? Can I get a thumbs up on your screen? Go down to reactions. Go down to reactions. They're down there somewhere in the bottom right. There's David's got him one. Yeah, Anthony, he's just giving me a thumbs up. All right. Jen, give me a thumbs up in the reactions. Then I know you're alive and well. There you go. All right. So I got a bunch of them. Cool. So let's move on. We had some code listings in chapter 6 to take a look at. And I want to talk about those before we do what's coming up next. And that's chapter 10. That doesn't even look like chapter 6, does it? Way to be ready today. Like I said, I was busy. All right, so a couple of code listings you had to type in. Let's get to that first one up there in the book. There's that UML chart. You notice this one doesn't have pluses and minuses in like I had talked about. And we're going to keep modifying this to give it more and more guts so that when I write my class, it'll look good. Okay, so my first rectangle looks something like this. I come in, oh, you know what I don't have in here? I don't have public, static, void, main. So if I type this in, would it run? No. And I'm sure some of you tried to compile it or run it and you got an error message, and that's why. It doesn't have a main, it's not going to run. I have my two fields, length and width. Then I start listing my methods. Here's one right away called set length. It brings a value in called len and stores it in len. Okay, this is my parameter list. Len has a value. It now gets assigned to this object's length. And as you went through, you kept adding to rectangle, set length, set width. Here we bring in a value. We have a local variable W. We bring it in and we store it in the class's width. So as you can see, rectangle, we kept adding and adding and adding. That's why I only wanted you to turn in that third version. Let's take a look at a demo program. So I have it all written. I come in, I instantiate an object, box. Oh, this is where all that old equals new comes from. We were instantiating objects of a class. Here's a class called rectangle. Remember, we saw this with files and a couple of different places. This name equals new name, and then this guy right here is my object. So that's come up several times up to this point in the semester, that format that you see right there. So now my object name is box. I set the length in box to be 10. I set the width in box to be 20. And then when I want to get it to print it out, box.getLength is returning a value and gets printed. Box.getWidth returns a value. So if I'm really good with my methods, when I'm doing classes, this is just a piece of cake. It's just reorganizing things. Okay. What did we add here? So we have the set and the set. What kind of methods are sets called?
Setters.
Close. They're called mutators.
Oh yeah, yeah.
Okay. Over on this next page, I have to get. What are the get methods called? It's a nice naming standard.
Getters.
Like accessors or something.
Accessors, yeah. So we have mutators, which are mutating or changing the values, and we have the accessor methods. They're my gets. So the get length and get width. So you were cruising right along up through code listing 6.8. We already talked about stale data. I'm now taking a look at section 6.3. Here's another UML chart for a class. I have two fields, and eventually as we modify these, we're going to say make. What data type do you think make would be?
String.
String. So, when I start to do my UML chart, if I have these included, it's going to make it easier. Year model. 1962.
Integer?
Could be an integer, sure. Could be a string, sure. I mean, the reason we might not make it an integer is, are we going to be adding to it or subtracting or doing some kind of algebraic operation? My instinct would be to make it an int, because ints are always easier to work with than strings, and I have sets and gets and so forth. So we take a look and we have an example. In this code listing, you notice I instantiate 3 different objects: a kitchen, a bedroom, and a den. The kitchen has a length and a width. It has its own length and width. That's different than the bedroom's length and width, and they are both different than the den's length and width. So even though I instantiated multiple objects, I have unique fields within each one. Do you have any questions on your code listings? Do you have any questions?
Yeah, can I ask a question quick?
Yeah.
So obviously, so one program is going to be where you like define your class, and then the
Yeah.
other program is going to be where you basically define all your objects. So the program where you have all your objects, can you have like separate methods in that one too?
Well, it'd be based on the object name.
Mhm.
Like it would be den.getLength and den.getValue or width. So that's going to determine which length and width to go get. Talking a little bit, does that help?
Yeah, yeah.
Okay. Talking a little bit more about what's going on here. Here's another UML chart called circle. What's the one and only thing I need to know about a circle? Its radius. Everything else can come from that. I don't need a field called circumference or area or diameter or volume. All of those are based on radius, and I want to base it on the current radius so that I don't have stale data. Okay, so let's see. I have accessor methods, has a return, mutators, change the value. We already talked about private and public. My class has to be in the same folder of a demo program or any kind of program that's going to use it. And I also mentioned that multiple objects have unique fields. That was the question that was just asked. If I have rectangle R1 and rectangle R2, R1's length and width are going to be different than R2's length and width. So if I say R1.getLength, it's going to give me this length. If I say R2.getWidth, it's going to give me this width. So they are unique. So when you're writing these programs, comment made a moment ago, should the class and demo program be separate programs? The answer again is yes. Just like rectangle was separate from the program that used rectangle. So now what we're going to do the rest of today is you're going to go and I'm going to put you in groups. You're going to make a class. And one thing that I don't like is that when we compile a program, it goes Java for our source code, .class for our bytecode. Well, don't get confused. That's different. That .class is just something stored. This is a class, but it's going to have a .java extension when I save this. All right, so I want you to create a class circle, nice and easy. Set radius, get area. Then I want you to have a program. Hey, please enter a value for the radius. Then you're going to set the radius. Then you're going to have some lines of code to test these methods. Get the radius back, get the area back, make sure everything's working. Sounds clean and simple. It's going to be a lot like rectangle. Do I have any questions?